Thank you, Tudor. I want to thank my co-authors from CISPA Saarland University and University of Maryland, and also NIST, who tremendously helped with this paper and also wrote this paper with me. And yes, I'm going to talk to you about how we compared the usability of cryptographic APIs. Before I talk about that, let me briefly reiterate that we all know and we've all heard that cryptography is hard for developers. And they fail again and again and again to implement cryptographic solutions in a way that they're actually fulfilling their goal of securing things. And the reasons for that are sometimes perceived as maybe the developers are just lazy, or they're not educated, or maybe they're just not motivated. Maybe the reason why they fail to do this is they're just not trying hard enough. They're not motivated in the way that it's not mattering to them. It's not the primary task, and why would they take care of that when it's competing with other things? But recently we've seen that even bad people fail at implementing cryptographic things correctly. And imagine you're the author of ransomware, and the success of your criminal activity depends on whether or not you implement this correctly and whether or not it works. And you might get jailed for failing to do this correctly. So arguably, you're extremely motivated to get this right, and you still fail. So the question is, if it's maybe not a lack of motivation, maybe the issue is not with the developer, but maybe it's with the usability of the API, that even if you're trying, you don't have a chance of succeeding, or don't have a high chance of succeeding. So there are APIs that are designed specifically for usability. And usability in the way that the API designers try to make the APIs simpler. They gave a limited set of choices. You had less options to pick from, so you had less options where you would fail. There were secure defaults given, and also fewer methods to call. And the idea, obviously, is if we do this, if we make this simpler, then people will have less opportunity to fail, and they will have a higher chance of succeeding. And our question here was, do these cryptographic APIs designed for usability and simplicity actually lead to better security? And we try to evaluate that, or we evaluated that in an online study with Python developers. We picked Python because it's popular. We could get many developers who are knowledgeable about it and were willing to participate. It has lots of cryptographic APIs, and some of them are designed especially for usability. So we looked at libraries to look at. The standard is PyCrypto. It's not made for usability. It's used a lot. And then we have M2Crypto, the binding to OpenSSL. We have Cryptography.io, which is made for usability. We have Quasar, which is made for usability, has very limited choices, and Pinnacle, which binds to NACL, a C library made for usable cryptography. We looked at different tasks that you could accomplish with these libraries, and not all of them supported all tasks, and obviously not all of them claim to be usable, but we still try to compare them. To do this, we designed a set of study tasks across which we would compare performances. We wanted to give everybody every task, and then figured out that it would take them longer than 2 hours to complete everything, and then we decided to split the tasks. So we had symmetric tasks and asymmetric tasks. For the symmetric set of tasks, you would have to encrypt and decrypt, and also to generate a key and to store it. And the challenge here was to get a strong key and to store it securely. Obviously the same for asymmetric tasks with asymmetric encryption, decryption, everything. But also in this case, we added certificate validation, where you had to do a correct signature check, and you also had to do hostname verification. The solutions could obviously be secure or insecure, and we manually evaluated them. First, we evaluated them for functionality, And for the ones that would work at all, we manually evaluated them for security. This was done with several researchers. And we had pretty good agreement, and in most cases where we didn't have, we did get to agreement. So we didn't work on a set of things that were not classified as one thing or the other, but we had unambiguous classification here. We did this as an online study, and the challenge here was that we wanted to observe as much as possible, so we developed an online study environment where we offered code skeletons, so people would have to write minimal amounts of code, and they had the possibility to skip tasks if they figured out that the library didn't support it or they just couldn't solve it. And with this thing, we could measure, or we could collect the code they wrote, the time they spent on every single task, and whether or not they copy and pasted things. When they did that, we prompted and asked them where did they get that from, and obviously also button clicks. After that worked on the task, we gave them an exit questionnaire where we asked them to themselves say whether or not they thought that the tasks individually were functional or secure. For that, we prompted them with showing them the code they had just written and asked for each individual task. We also gave them the SUS score, which is a standard tool to evaluate usability. In this case, it had a bit of a problem because it's not made for APIs, so it has questions that don't perfectly fit here. And it's also not diagnostic. You're asked whether or not you like working in it, if you thought it was easy to use, and also if you would recommend it. But if not, that wouldn't help us identify what the issue actually was. So based on cognitive dimensions that was worked on at Microsoft, we came up with our own set of usability questions that in the end turned out to correlate with the SUS, but that was diagnostic. So we would know whether the documentation was the problem or whatever else was the problem, maybe the level of how abstract the API was. In the end, we also collected demographics. Most importantly, we wanted to know how much experience they had with Python and their security experience. We recruited people with Python experience from GitHub. We did that by crawling Python repositories and randomly inviting 50,000 authors who had contributed there. We could not offer them compensation, sadly, but we still had 256 valid participants. 6 times as many started but dropped out at various points in the study. 200 of them were professionals and 200 of them were without any security background. To see whether we had a very strongly biased sample who had opted in, we compared the people who had participated in a valid way with the sample that we had invited. And as you can see, the left ones are the invited ones and the right ones are the valid ones. They are slightly more active in everything they do. But that's not super surprising because obviously if you engage more, you will also maybe engage more in surveys that you're asked to opt into. So jumping to the results, everybody took roughly 1 hour. And of course, we gave everyone one library to use. We asked them to use that library. We pointed them to the documentation. We showed the tasks in a randomized order and everything. And I'll just report results now. Across tasks, the success rate for functionality differed. It did also, of course, differ per library, but also strongly per task. So on the x-axis, you can see the percentage of tasks with functional solutions at all. And yeah, obviously some APIs are worse than others, but across everything, asymmetric tasks were harder to solve. And the hardest to solve is the dark blue thing all the way down in every single column. And you see that certificate validation was the hardest to solve functionally. We looked at security too, and found that here secure key generation and storage was hard. And we didn't find a single implementation of secure certificate validation, which kind of corresponds back to the papers that we have just looked at. After that, we corrected for tasks in the remaining analysis. So we're now looking at functionality results by API. You can again see the percentage of tasks that had functional solutions. And you can also see that Quasar performed the worst. So this is a library that was simplified, where you didn't have a lot of options, and it obviously didn't allow to solve all these things, but it didn't. So yeah, it was just harder to solve things with it if it was not if the option was not directly given. I had said that we measured whether or not people had copied and pasted code from somewhere, and in this case, it had a huge impact on whether or not they were able to successfully or functionally complete the task. If they copied and pasted, then the likelihood that the task was going to work in some way was higher. For security, we can see that Quasar, which had the lowest number of results that worked at all, has the highest likelihood of having secure solutions. And this is now kind of, we're looking at, on the one hand, things that are very easily doable, and these are obviously doable in the way that they then just work correctly, securely. And on the other hand, there were people who had to look into the source code of Quasar to figure out what it did. And these were obviously the most skilled ones who then did not drop out or did not solve the task, and who did this thing, and who were then able to come up with a secure solution. So this is kind of, you need to take this result maybe with a grain of salt. And you can also see that we evaluated statistically as well, but you can also see that PyCrypto and M2 crypto, the ones not designed for usability, performed the worst here. What was then the differentiator? So the usability, as measured with the SAS, helped the most with functionality. Quasar and M2 crypto were worst according to that. They had scores that were around 30. But none of all of them had more than mediocre scores. So if the goal of these APIs had been to, if this was a usability test and we wanted to say, like, we developed this and we want everybody to use it, then this would be a very, very bad result. And also we found that designing for usability by designing for simplicity does not necessarily lead to good usability, as we have seen it with Quasar. What could differentiate, and which we found in our own set of questions, was good documentation. Cryptography.io offers low-level functionality as well, and they have helpful documentation. And we had various comments, and we could also see in our results that the results were just more secure, or more likely to be secure, and also to work. So this is what we want. We want things that work, and we also want things that are secure. I can't even say what's worse, something that works and is insecure, or something that just doesn't work at all, so that people will then go do something that works, which then might again not be secure. So this leads me to, we need full functionality, because if you, as Quasar does, only offer a small set of features, then people will just go use something else. They will be unable to do whatever they set out to do, and then they're again on the market and shopping around for something else to use. One could now think, maybe if we just educated developers better, maybe this helps, and we corrected for that. So the experience level with Python did not matter on those metrics. The security background, this was only very few people had security background, but it almost mattered a bit to security results. But not in the way that you would expect it to help. So bullying people into taking security classes is still not the one way to go to get everyone to write secure code. Another scary thing we found was a huge gap in security perception. Of the functional solutions, 20% across all APIs were believed to be secure when they were not. So these are the code pieces that are going to be pushed somewhere, they are going to be looked at, and they are going to be perceived as secure when they are not. And what do we take away from this? So again, implementing cryptography is hard. It's hard for everyone, regardless of whether or not you're an expert or even a security expert. And it's also, when you design an API for which security matters, it's not sufficient to design for simplicity. Usability is not just simplicity, and we've seen this, we've tested this, and it's not enough. You need to test your usability to actually figure out if the decisions that you made to make things more usable are actually making the thing that you wrote more usable. We developed a set of diagnostic questions that correlated with SUS that you may use to test this. Also, a full feature set is super important, otherwise developers will just go use something else. And documentation is important, super important for usability and security, and usability in the sense that it helps with getting a result at all or being able to use it at all. And it's important that people take ownership of that documentation, because if they don't, and if they don't offer options to search for example, code snippets there, then people will just go search somewhere else, maybe Stack Overflow, and we've heard what happens when you do that. Thank you. I'll take questions.
Thanks, Yasemin, for this very interesting presentation. So we have time for a few questions. Go ahead.
Isaac Schaff, Cornell. And I just have a question about your experimental setup. You said you had 256 participants, and you divided them amongst 5 libraries with, I want to say, 5 tasks each. Does this mean that there are about 10 participants on any given task?
We put them in task sets, so there were 2 sets of tasks. So we had between like 15 and 20 something, 30 sometimes for the different groups. So we were able to statistically evaluate this. So we would have preferred to have fewer options to sort them into, but we couldn't eliminate anything from that. Thanks for the question.
Mihai?
Mihai Cristodorescu, Visa Research. This is a very interesting study. I was wondering how this compares in terms of usability with non-crypto APIs. So, the result usability score here is mediocre, I think, from what you reported. How are the non-crypto APIs viewed by developers?
I wish I knew that. I don't know that. I should have this to compare it to. I don't know. I could speculate that if you solve tasks that are less hard, then the usability will maybe not be perceived as bad, because you don't have to spend so much time on things. So maybe the usability also scales with the complexity of the task, and we should maybe have we should not give too much weight to this bad SUS score, because maybe when you try to implement something that's incredibly hard, everything is going to have a bad SUS score. Yeah. I take this as they did not like the usability. Thank you.
Sam.
Sam Weber at NYU. So you said that it helped to have better documentation. Do you have an idea whether documentation was good because it just matched what the users actually wanted to do, or because it conveyed the concepts better?
From our old study, last year we looked at people actually writing code and using documentation. And what everyone looked for was either code snippets, if they knew the concepts but didn't know how to write the code. And also sometimes concepts that maybe did not, in a few cases that explained the concepts of what they were trying to do, but in a few cases also that explained how to use the API. So all of these, what they actually ended up taking from somewhere else were code snippets. So I believe brief descriptions and brief concepts, but most importantly, configurable, easy-to-use code snippets would be what I'd say was looked for.
So it looks like so many years later, Johnny still can't encrypt, even when Johnny is a developer who should know better. Right? Those usable crypto libraries that you listed, my impression is that the main way they make them more usable is by making them simplified, right? So removing options from the developer, right? So can you comment a little bit about what else could we do to make things more usable?
So actually, in one case, this was not true. For cryptography I/O, they had lots of options paired with good documentation. And this was the best, leading to the best results. They had, people were able to solve simple tasks easily, but also to solve more complex tasks because they were given help. So I believe that this is maybe the way to go, to not omit functionality, to just support people in making these choices by supplemental documentation.
Let's thank the speaker once more.